let's evaluate these two integrals. So the first one, we have integrals goes xu goes from 0 to 1. We have a product of two factors. So how do we deal with this kind of integral? So first, you have to FOIL. You have to fully open up the two products. So you have from 0 to 1, just algebra problem. U times u is u square, and then u times 3, 2 times u, so 3 plus 2, you get a 5u, and then 3 times 2 is equals to 6, and then du. Now you can just apply the simple power rule. So this is u 2 plus 1, 1 divided by the power, plus u 1 plus 1, 5 divided by the power, plus 6u, u goes from 0 to 1. And then that is 1/3 u to the third plus 5 over 2 u square plus 6u. Take a look, take the derivative of this, you can easily go back to the integrand, right? The derivative of u to the third, bring the 3 down, and then 3 minus 1, bring the 2 down, 2 minus 1, 6u, the derivative is just 6. And then goes from 0 to 1. So the first one is 1/3, 1 to the third power plus 5 over 2, 1 square plus 6 times 1. And then subtract. Oh, the other one will be just all 0, right? So 0 to the third plus 5 over 2, 0 square plus 6 times 0. So the second square bracket is all 0. So overall, that gives you a 1/3 minus 1/2 minus 6. So you have negative 37 over 6. So that is the answer of the first one, the green one. And then the pink one, the reason I bring that up is I want you to review how to open up a higher power. So 1 plus r to the third, 1 plus y to the third, 1 plus y to the fourth. How do you take care this higher power? To take care the higher power, you have to use Pascal triangle. This is what I want you to review. So what is Pascal triangle? Pascal triangle is used for open up higher power like this. So Pascal triangles, if you have your own method to do it, if you have your own method to do this, use it. So Pascal, the top of the triangle is 1, and then the next line is 1, 1. The next line always starts at 1, and then the next number is 1 plus 1 equals to 2. It always ends with a 1. So start with a 1. 1 plus 2 is 3. 2 plus 1 is 3. And then 1. Start with a 1. 1 plus 3. 3 plus 3. 3 plus 1. And then ends with a 1. This is called a Pascal triangle. The triangle can keep going on forever. Okay. So since this is a third power, then we don't consider the top. So this is the first power, this is for the second power, and then this is for the third power. So for the third power, how do we use the 1, 3, 3, 1? The 1, 3, 3, 1, they are coefficient. So for 1 plus y to the third, so you write these coefficients down, 1, 3, 3, 1. And then since that is a plus, then this will be all plus. What about the 1 and the y? So here is how we do it. So the 1, so that will be 1 to the third power, 1 to the second power, 1 to the first power, and then 1 to the 0 power, which is just 1. And then on the right hand side, y to the third, y square, y to the first, and then y to the 0, which is 1. So after you open this up, this is a 1 plus 3y plus 3y square, and then plus y to the third. Now, you might ask me, hey, what if I have 1 minus y to the third? So that would be 1 minus 3y plus 3y square, and then minus y to the third. So the pattern of plus is all plus. The pattern for minus is plus, plus minus, plus minus. So that's how you open up a plus and a minus. All right. So now back to this problem. So what is that equal to? So that will be the integral 0 to 1. So we have 1 plus 3y plus 3y squared plus y to the third. If you have your own method to open up a binomial like this, use it. dy. Okay, so now simple power rule. So this will be a y, right? And then this will be y. 1 plus 1 is 2. So 1 plus 1, and then 3 divided by their power. And then 2 plus 1, 3 divided by their power. And then 3 plus 1, 1 divided by their power, goes from 0 to 1. So let's use all the space. So we have a y plus 3 over 2 y squared plus y to the third, and then plus 1 over 4 y to the fourth. Y goes from 0 to 1. Now, check your work. When you take the derivative of this, you go back to the integrand. Just check, take a look really quick. Take the derivative. So that goes back to the integrand immediately, right? Okay, now let's apply the fundamental theorem of calculus. We plug in a 1, so that will be 1 plus 3 over 2, 1 square, plus 1 to the third, plus 1 over 4, 1 raised to the fourth power. So we just finish the 1 and then the 0. That will be all 0. I will just write it for you anyway. 0 plus 3 over 2, 0 square, plus 0 to the third, plus 1 over 4, 0 to the fourth. Alright, so the second square bracket is all 0. If you take care of your math carefully, the answer of this integral is equals to 15 over 4. Alright, so that is the end of this video. If you think my instruction is helpful, please let me know in the comment below. Like, subscribe, and share the video for me. I appreciate your help. I will see you all in the next one. Signing out for now.